Hello, good evening, Bearcats. I'm sorry it's so late tonight. I had a little technical difficulty in a very late meeting at work, but I am here, and it is 4.3. We are moving on to right triangle trigonometry, which you actually know quite a bit about, and a lot of this will seem a little repetitive. We will begin some identity work tomorrow, which is new, so we need to be, I guess, tuned in and stay tuned in. All right, here we go. Right triangle trig. I'm going to go and draw our basic right triangle. And we'll call this angle our theta. And so across from theta would be your opposite side. Adjacent to theta or next to theta would be your adjacent side. And across from the right triangle, of course, is your hypotenuse. So just so you know, then that's how our sine value is opposite over hypotenuse, cosine adjacent, tan opposite. And of course then we have our reciprocal identity, our reciprocal functions of cosecant, secant, and cotan. This is all stuff that you really do know. These are the 6 trigonomic functions. I think that's kind of important wording because sometimes you get lost in the words. So 6 trigonomic functions. And know that the functions in the second row are reciprocals corresponding to the first row. And that's really all basic. You want to have that in your notes somewhere. I'm going to move on, but you may pause to take your notes. Going on to the next page. Again, these are things that we have already done, but I just want to reiterate them because we will continue to use them and have to know them very well. This little table is really good. This is the same as our cosine, sine, and our cosine, sine, and tan of our functions on our circle. This is just written in a table form, and they've actually written it as sine, cosine, and tan. Now, I would suggest strongly, like trust me. Oh, what am I doing? Okay, there you go. Our trust me. I would write this table, except I would reverse my sines and my cosines. I would write my cosines first, then my sines, then my tans, because then you're continuing to reinforce that connection with the unit circle. Because remember, our cosine are x values, our sine are our y values, our tan is y over x. And this would be our ordered pair along the circle. I really strongly suggest that you write it in reverse right there. So when you're taking these notes, I would just reverse these. But this just reinforces our degrees, our radian measure, and then our value at that location. All right, next I want to make a note of something we've sort of touched on but we haven't really talked about. I want you to know that these are co-functions, and we want to talk about that. Okay, so in your notes, make sure you label this co-functions. That's kind of an important word for you. Notice in the box above that 30 degrees is 1/2, and that is cosine at 60. And we've talked about the relationship between 30 and 60 degrees. So our cosine at 30 is 1/2, and our sine at 30 is 1/2, and our cosine at 60 is 1/2. There's this co-relationship, or this inverse relationship with 30 and 60 degrees. So noticing that these are complementary angles. In general, it can be shown that the right triangle definition that cofunctions of complementary angles are equal. That is, if theta is an acute angle, the following relationships are true. So it has to be stuff in the first quadrant, so they're acute. So sine 90 minus theta equals cosine. In other words, if I took that and we said 90 minus the sine value, so let's say 90 minus 60, that would be the cofunction, then cosine would be, these are all just complementary angles. So theta could be anything in that first quadrant. So if I had the sine value, of 90, and let's say minus 30, that would equal the cosine value of 60. Okay, and the same thing with cosine. 90 minus 30 would be the sine value of 60. And that's just a cofunction. I would have these written down. We don't use them tremendous amount, but we do use them, and they will come up in some of our proofing. So make sure you have them written in your notes. I'm a little tired. Sorry if I'm rambling too much. Let's move on to our next to last page. All right, finally, our trigonometry identities. This is our first look at identities. This is really, really important. I would put these in your notes. And please don't let me forget, right at the beginning tomorrow, I want us to create our unit circle. And or get your green card out. I want us to make sure both unit circles are filled in. You can use the second one as practice if you haven't already. And then really what I want us to do is focus on what we should have written on our green card right now. We want to talk about that and recap to make sure everybody has it written down. So we want to make sure we have good notes on our green card. We need to do that tomorrow before we even begin. I would add this to my notes, and we will add this to your green card, but I want to make sure we have everything kind of in order first. So some of the other stuff that we've already talked about needs to be on there first. These are our first look at identities. Next week we'll do an identity page, and you'll have an actual page with all your identities, but for a while these are the ones that are so important. We have our reciprocal identities, and we've talked a lot about that, and they're written this way, and this is how you have to think of them, that sine is 1 over cosecant, and cosine is 1 over secant, and tan is 1 over cotan. And you know that because those are the partners. I call these are their friends, these are the buddies. Then you can go reverse of that. If you have cosecant, that is equal to 1 over sine, secant 1 over cosine, cotan 1 over tan. Really, really important identities, and you'll be using them a tremendous amount as we start to prove. All right, quotient identities. I like to add this on to my tan and my cotan values. So I like to add this on. I'm going to actually erase my little question mark for a second. Oops, didn't get the eraser. I'm going to erase that because I want to put this in there. So I would actually extend this. So tan theta is equal to 1 over cotan, but it is also equal to sine theta over cosine theta. And think about that. Haven't we always said that tan is y over x? And haven't we said that sine is y and cosine is x? Cosine is x, sine is y. So that's kind of important to also note. And then for cotan, because they are reciprocals, you would flip this and it would make it cosine theta over sine theta. And cotan is x over y. X over y. And then secant is 1 over x, and this is 1 over y. So I might add that to that little chart of your identities just to kind of keep everything reinforced. So this you could add up here. Last, though, are the Pythagorean identities, really important. And there's actually a lot more versions of this, but these are the 3 key ones. From this, you can manipulate them, and I want to do that for you right now because you'll need to know all these manipulations. We can take sine, the first one right here, squared theta plus cosine squared theta equals 1. And we can manipulate this around. We could say that sine squared theta equals, and we could move cosine to the other side, 1 minus cosine squared theta. We could go back to the original and say that cosine squared theta is equal to 1 minus sine squared theta. So there's a manipulation of the first one. Let's look at the manipulation of the second one. We have 1 plus tan squared theta equals secant squared theta. Again, we could move tan over and get we would have secant squared theta. We would move tan minus tan squared theta, and that would be equivalent to 1. Or we could move the 1 over and say that tan squared theta is equal to secant squared theta minus 1. And all of that would be a manipulation of the second one. You could do the same thing with the third. Please do not let me forget tomorrow. This one is really pretty easy to remember. I have a little way to remember this that's really kind of funny, and you have to ask me, and I'll tell you, and you will never forget these 2 identities. It's a very easy way to remember these 2 identities. So ask me tomorrow in class, and I will be happy to share with you. All right, last is something I'm going to have you do tonight and bring to class with you tomorrow. It will shorten your homework or your classwork tomorrow in class. I need you to work problems 17 through 26. This is all from memory from your unit circle. So you really should try to do this without even recreating your circle. I'm just going to start off. So you know that 30 degrees is the same as pi over, and I'm going to pause for a minute, pi over 6. and you would fill that in. And then what's the value of sine at pi over 6 or at 30 degrees? You're just going to fill this in. All of these come from the unit circle. So you can create the unit circle if you want, again, just to practice, or you can try to think, can you think yourself through that without too much effort? If you can, you are a star. All right. Actually, you're a very good Bearcat. Anyway, hope you have a good evening, and I'm sorry again it got on so late. I will see you tomorrow in class. We actually have book work we're going to work on in class tomorrow, and have a good evening. Night, Bearcats.